So, good afternoon guys, welcome to NEET World of Physics. Today we are going to see a bridge course of module 2. So, in yesterday's class we have discussed about the exponents and powers. So, in exponents and powers where we are using in physics of class 11th and 12th. In laws of motion, energy equation as well as kinematic equations also we will use the exponents and powers. Kinematic equations. So, some formulas we have seen like 2 square, then 3 cube, etc. in the exponents and powers. So, next topic is algebraic manipulations. So, in class 10, 9 and 8 in mathematics we have seen about linear algebra or linear equation, quadratic equation and polynomial. So, for example, if I write ax plus b is equals to 0, in this case a and b are constant. I need to find what is x. This is I will say as linear equation. If I talk about the quadratic equation, the power will be 2. So, ax square plus bx plus c will be equals to 0, where a, b, c are constant. In this case I need to find value of x. So, in the first equation the value of x will be only 1, like one real values will be there, but if I take the equation 2, the quadratic equation, I will get 2 real values. So, here 1 real value, this one is a quadratic equation, I will get 2 real values. Okay. So, if I talk about the cubic polynomial, the powers will be 3 and then greater than 4. For example, ax cube plus bx square plus cx plus d is equals to 0. This is cubic equation, we will say, where the power is 3. The maximum power we need to see, and in the equation then we can say that either it is a linear equation, quadratic equation, cubic equation, or it is a polynomial. Okay. So, we will go into the topic. So, what it means? First of all, we will see from the basic terms. So, changing or rearranging a mathematical expression or equation using basic rules of algebra, like simplifying, factorizing, solving or substituting to the equation to make it easier and get the values. Okay. So, in the previous classes like 10th, 9th and 8th, you have done what is simplifying. For example, if I take ax plus b is equals to 0, I need to find what is the value of x. So, I can take the value of b and a on other side. So, ax is equals to minus b, where x is equals to minus b by a. This is how we will simplify the equation, right. Next, the first point, transposition of terms. So, moving a term from one side of the equation to the other side by changing their sign. Now, we have seen that is ax plus b is equals to 0. When I change the equation, like when I change the term from one side to other side, the equation of the term sign will be changed. It is plus, it will go as a minus. So, this is ax is equals to minus b. So, x will be equals to minus b by a. So, for example, I have taken here f is equals to ma. This is a force equation, right. F is equals to ma, where f is force, m is mass and a is the acceleration. So, if I want to find what is acceleration, f is equals to m into a. Take this m to the other side, I can get force by mass as the acceleration. Now, the second one, combining like terms. Combining like terms means, like for example, 2x plus 3y plus 2x is there. So, 2x and one more x term is there, I can combine the terms. So, for example, here 3x plus 3x, I can say it is a 5x, and a square plus 2a square, I can say it is a 3a square. I will take some more example here. 3a square plus 2ab plus 4b square minus a square equals to 0. This is the given equation. In this, a and b are constant. So 3a square is there and one more a square is there. So I can combine the values, no? 3a square minus a square will give 2a square. So 2a square plus 2ab plus 4b square will be my answer. So 2a square then plus 2ab plus 4b square will be my answer. This is how we will combine the terms. Next one is substitution method. So replace known values or expression into equations. So for example, like kinematic equation I have taken. So v is equals to u plus at, where v is final velocity, u is initial velocity, acceleration and time. So this is equation number 1 as I mentioned. Equation number 2 is a is equals to f by m, where a is acceleration and force by mass. So two equations are there. So v is equals to u plus at, equation number 1. A is equals to f by m, equation number 2. So I can take equation number 2 and substitute in equation number 1. So v will be equals to u plus of f by m into t. This is how we will substitute when two equations or more than two equations have been given. So next is factorization and expansion. Okay. So first one we will see what is expansion. Suppose in exponents and powers, no, we have seen that 2 square means 2 into 2. Similarly, in this case, like we are dealing with constant, right? So x plus y the whole square. X plus y the whole square means I can say this is x plus y into x plus y, right? So x into x, first one, again x into y, taking the first term and multiplying with this whole term. Next I will take this second term and multiply with x as well as y. So what I will get here? First x square plus xy, again plus xy plus y square. So if I equate this like equation, final equation I will get as x square plus y square plus 2xy. Okay, this is how we will expand the term. Now factorization. In factorization, like x square minus 9 I have taken, x square minus 9. So if I see this 9, no, this is looking like 3 square, right? 3 square. We know that formula like a square minus b square. Like in upcoming slides I will say what are the formulas are available, but in the basic classes we have seen a square minus b square, right? I can say this one as a plus b into a minus b, right? So in this case, what is a? This is x. In b is this is 3 square, no? Like I can say that x square minus 9, I can write this one as x square minus 3 square, where x is said to be a and 3 is said to be b. So if I expand this one, x plus 3 into x minus 3. So if you have any doubt, no, we can solve this equation first here. So x into x, I will get x square, x into minus 3 minus 3x plus 3x plus 3 into x 3x, 3 into minus 3 minus 9, minus 9. So minus 3 plus 3 will get cancelled out, I will get x square minus 9. So this is how we will factorize it. Okay. So expansion, factorization. So till now we have seen what is transposition of terms, combining like terms, then substitution method, factorization and expansion method. Next we will go for cross multiplication. Cross multiplication. Okay. So in this, like it is used when dealing with ratios and propositions. So for example, I have taken a by b, like it is in ratio, no, a by b is equals to c by d. If this kind of equations are there, I can say that a by b is equals to c by d. I can cross multiply this one, no? I can cross multiply. See, in this terms, no, any three values, like three values are there, one will be unknown. By using cross multiplication, I can find the unknown, right? So if I cross multiply, I get AD is equals to CB. AD is equals to CB. This is how I will do cross multiplication. Next is solving linear and quadratic equation. This is how, like this is what we have seen in the first slide itself. See, for linear equation, no, the power will be 1. For quadratic equation, the power is 2. So mostly we will deal with quadratic, okay? Quadratic we will deal. So ax plus b is equals to 0. If I want to find what is x means, it is minus b by a for the first equation. For the second equation, there is a simple way. If I want to find x, no, x is equals to minus b plus or minus root over b square minus 4ac by 2a. Okay, this is how we will find x for the quadratic equation. So two real values are there, no, for this one, two real values. I have written only one here, that is minus b plus or minus root over b square minus 4ac by 2a. I can say this one, x1 will be equals to minus b plus, I will take only plus, under root of b square minus 4ac by 2a. Then second one will be x2 will be equals to minus b minus root of b square minus 4ac by 2a. So one value will be x1, another value will be x2. One is minus b plus, one more is minus b minus. One more thing, like in the up to 10th classes in maths, no, you have seen that what is real roots and imaginary roots. So mostly will, like in the questions will be real roots only. If any doubts are there, no, if I want to find whether it's a real roots or imaginary roots, take this b square minus 4ac, like b square minus 4ac is there, no, take the values and substitute the values, like b is constant, like ac also constant. If it is greater than or equals to 0, it is a real root. Suppose b square minus 4ac greater than or equal to 0, it is a real root. In case b square minus 4ac less than or equal to 0, it is a imaginary root. Understood? So whether it is a real root or imaginary root, I can find by using b square minus 4ac greater than or equal to 0 or less than or equal to 0. Next one. So dimensional consistency via algebra. So dimensional consistency means, see, for example, we know the dimensional formula like units of velocity or speed, it is meter per second, right? In this question, like in this equation, what is the equation given? V square is equals to u square plus 2ac, so 2as. Okay, the unit for velocity, this is velocity, right? Velocity, acceleration, and this is displacement. I will write the units here. So for velocity, that is final velocity, I will write here, velocity meter per second, velocity that is initial meter per second. For velocity it is meter per second. What about acceleration? Meter per second square, like velocity divided by time is the acceleration, right? So then what about displacement? It is in meter, it is in meter. So take these values like dimensions, substitute here, meter per second the whole square should be equals to, again, meter per second the whole square, right, plus this is constant, I no need to worry about the constant, I need to worry about the dimensional consistency. No need to worry about the constant, leave constant as it is, meter per second square into meter. So meter per second the whole square will be meter square by second square should be equals to meter square by second square plus meter per second square into meter, again meter square by second square. So meter square by second square plus meter square by second square will be 2 meter square plus I mean meter square by second square. So I can write this as 2 meter square by second square should be equals to meter square by second square. No need to worry about the constant, I said no. So if I see the dimensional unit, it is meter square by second square. Understood? This is how we will see a dimensional consistency by algebraic method. So some basic formulas which we are going to use in algebra in upcoming classes. So first one is a plus b the whole square, which is a square plus 2ab plus b square. Next is a minus b the whole square, which is nothing but a square minus 2ab plus b square. See, whatever the formulas we are discussing now, try to remember. Okay. Next is a square minus b square, that is a plus b into a minus b. Fourth one is x plus a into x plus b, like two constants a, b. I can say this one as x square plus a plus b of x plus ab, right. Next is a plus b plus c the whole square, a square, b square, c square, like a square plus b square plus c square plus 2ab again plus bc, like come like this, a, b, c are there, first you take ab, next bc and then ca. Okay, this is how we will use the formulas. So 5 formulas we have seen. Next one, factorization formulas. X square plus 2ax plus a square is nothing but x plus a the whole square. See, this formula and this formula both are same only. Here we have taken x and a, here we have taken a and b, that's it. Next one, x square minus 2ax plus a square, simple, a minus b the whole square we have seen, no, that only, x minus a the whole square. Next is x square minus a square, which has expanded as x plus a into x minus a. Next is cube identities, a cube plus b cube, right, a cube plus b cube. So a plus b into a square minus ab plus b square, right. Next is a cube minus b cube, which is nothing but a minus b into a square plus ab plus b square. So these are the formulas which we are going to use in algebra, that is linear equation or quadratic equation. Okay, and cubes also I have given some cubes. Okay, see, now we will see what are the topics involved in the algebra. Like if I see first one, Newton's law, the topics Newton's law, kinematics, work power energy, motion on an inclined plane or straight line also we will see. Next is Ohm's law. So these are the topics which are involved in algebraic usage. So the equations, for example, I have taken. So F is equals to ma, then v square is equals to u square minus u square plus 2as. Next is work done is equals to force into displacement. Next is a is equals to z sin theta, v is equals to ir. You have seen this equation now in the 10th classes, like voltage, yes or no. Next, algebra used, like rearrangement, substitution method, simplification, transposition, like all the methods we will use in the equations. Okay. So these are the practice question. So offline students, do this question. In online, whoever watching, please try to answer the question in the comment boxes. See, in the first question they given that v is equals to u plus at. I need to express t in terms of other variables. So, these are the variables. I need to express t is equals to the remaining variables. Second one, expand the equation and simplify the variables like constant in those equations. Third one, I need to keep v one side and remaining term other side. Fourth one, what they have given, v is equals to IR and I is equals to q by t. Express v in terms of q, r and t. I need to substitute the value of I in terms of first equation and I will get v in terms of q, r and t. In the fifth equation, there is a equation I need to solve this. This is a quadratic equation, right? I need to solve this by using x is equals to minus b plus or minus root over b square minus 4ac by 2a. So, before that, whether check that it is a real root or imaginary root. Fine, solve it. So, what is the answer for the first question? T is equals to v minus u divided by a. Okay. See, take this u other side, so it will become plus 2 minus no. So, v is equals, so v minus u by a, that is it. So, second question, a minus b whole square, what is the answer? First expand this one, a square plus b square minus 2ab, substitute the values now for a and b. A square plus b square minus 2ab, so value of a I substitute 2 square plus 3 square minus 2 times of 2 into 3. So, 4 plus 9 minus 4 and this is 12, 13, 12, 1, right. So, one more thing, whenever you are solving the equation, no linear equations or quadratic equation, use Bode-Mass or D-Mass method. You have remember Bode-Mass or D-Mass. So, D is nothing but first I need to apply the division, next is multiplication, addition and subtraction. So, I have first added the values and then I have subtracted. Okay. So, remember this one, remember this one. What is the value for third one? Yeah, v is equals to 2as minus u square, that is in under root. See, if I take this u square on other side, no, it will become, sorry, it is plus 2as plus u square in under root of that. So, v is equals to under root of 2as plus u square. Fourth question, two equations are there, like this is equation number 1 and this is equation number 2. So, equation 1 v is equals to IR, equation 2 is I is equals to q by t. When I take this equation 2 and substitute in equation 1, right. So, this is q by t into r, this is the value of v in terms of q, r and t. Fifth question, I will erase this one. I will go to next slide. So, x square plus 5x plus 6, I will write here x square plus 5x plus 6 is equals to 0. This is the equation. So, first thing I need to check whether it is a real values or imaginary values. First one, b square minus 4ac greater than or equal to 0 or less than or equal to 0, I need to check. What is value of B here? See, compare this equation with ax square plus bx plus c is equals to 0, where a is equals to 1, constant 1, right? Then b is equals to 5, c is equals to 6. Take this one, b square, that is excuse me, what is? Yeah, 5 square minus 4 times of 1 into 6, that's it. I need to check whether it is greater than or less than. So 5 square is 25 minus 24. So 1 greater than or equal to 0, right? So I can say it has real roots. So now apply the formula. X1 is equals to minus b minus root of b square minus 4ac divided by 2a. Second formula, x2 is equals to minus b plus root of b square minus 4ac by 2a. Get the answer now. So first one, x1 is equals to minus 5 minus root of 5 square minus 4 times of 1 into 6 divided by 2 into 1, which is equals to minus 5 minus of, this is value is 1, no, we got the value of b square minus 4ac as 1. So under root of 1 divided by 2. So root 1, what is 1 only, no? So write it, minus 5 minus 1 divided by 2, which is equals to minus 3. Minus 6, no, minus 6 by 2 minus 3. Okay. Next one, x2 is equals to minus 5 plus under root of 5 square minus 4 into 1 into 6 divided by 2 into 1. So value of under root is 1, minus 5 plus 1 divided by 2, which is equals to minus 4 by 2, which is minus 2. Understood? So these are the values we got. One is minus 3, one is minus 2. So x is equals to minus 3 comma minus 2. This is the answer for the last question. Hope you got how to do the algebraic, right? Next one, some additional formulas we will see. Okay, some additional formulas in algebra. See, first one, binomial approximation method. So try to understand what are the methods we are going to see in some additional formulas. Okay. First one, the binomial approximation method is used in physics to simplify and express in involving powers of binomials, especially when a variable is much smaller than 1. Suppose if I take the variable x, if x is less than 1, like much smaller, like if it is much smaller than 1, I can use the binomial approximation method. Okay. For example, see, this is not 1 plus x into 1, it is 1 plus x power n. Okay. So I will write it here, 1 plus x power n, where I have taken that x is much smaller than 1. So if I use this condition, no, I can write this as 1 plus n into x. Take this n and substitute in front of x. Suppose 1 plus x into minus n is there, minus n, where x is much smaller than 1. What I should write here now? 1, take the value here, minus nx, minus nx. So whatever the power sign is there, no, apply the power sign also there. That's the conditions for binomial approximation. Next, where binomial approximation is used in physics, the concepts or chapter in gravitation mostly will use the binomial approximation method. Okay. Applications like gravitational potential energy near Earth's surface. So Earth, when I take, no, it is r, radius is r. Near the Earth's surface, I will consider some value height h. Okay, in those cases I will use binomial approximation method. I will show the example here. See, for example, binomial approximation like G is equals to Gm by R square, where G is the gravitational acceleration. Like you know G is equals to 9.8 into meter per second square. So where capital G is gravitational constant, m is mass of the earth and r is the radius of the earth. Suppose G dash is equals to Gm by r plus h whole square is the given equation. In this case, if I take the earth surface, no, this is the radius. If I consider some value height h, is it greater than or smaller than r? It is smaller than r. So h is much smaller than r. When I take a person's height and compare with earth radius, it will be much smaller than or less than. So h like much smaller than r. So h by r less than 1. This is the condition. Let me keep this condition as it is. Now go to the equation. G dash is equals to Gm by r plus h the whole square. Take r square outside. R square outside. Can I write like this one? No. Gm by r square into 1 plus h by r. The whole square. Okay, if I take the r square commonly outside, I can write 1 plus h by r the whole square. Okay, see, take this r square inside, no, r square into r square by r square, yes or no, it will get cancelled out. Okay, so this value g, right, the value of this one is g. I can write this one, no, like g into 1 by 1 plus h by r, 1 plus h by r. If I take this value, that is whole square. Wait a minute. G into 1 plus h by r the whole square. If I take this value to the numerator, it will become 1 plus h by r power minus 2. I can write, I will write here. So G dash is equals to G into 1 plus h by r power minus 2. So when I take the condition no here, h by r is much less than 1. So if I apply the condition, this is binomial approximation method, right? So G into 1 minus 2h by r is the value of G dash. Understood? So this is how we will use the binomial approximation method. Next is component and dividend rule. Component and dividend rule. So this rule is applied in the ratios, when the equations are given in the ratios. For example, like this is the mathematical tricks to simplify the ratios. A by B is equals to C by D. The formula is, important formula is, see, A by B is equals to C by D. Take the like denominator A plus B, okay, divide by A minus B. A plus B by A minus B is equals to C plus D by C minus D. This is the condition. So whatever the values are there, same values only, A plus B divided by A minus B is equals to C plus D by C minus D. Useful when simplifying expression when two ratios are there. I said no, two ratios, like when they are in the ratios are equal, especially useful in the optics. So we are mostly use this conditions in optics, ray optics, wave optics, okay, and motion problems. So when component and dividend rule used in physics, like in the concept like optics, that's it. In application, deriving lens maker formula, lens maker formula. So, we will see the example here. So, sin I by sin r is equals to mu 2 by mu 1. How to write this one? Sin I by sin r is equals to mu 2 by mu 1. We have seen the condition, no? What is? It is mu 1. So, a by b is equals to c by d. Take this a as it is plus denominator divided by numerator minus denominator. Numerator plus denominator by numerator minus denominator is equals to c plus d by c minus d. Apply the condition here. Sin I by, so sin I plus sin r by sin I minus sin r is equals to mu 2 minus, sorry, mu 2 plus mu 1 by mu 2 minus mu 1. Yeah, understood. So, this is how we will use the conditions. So, mostly these kind of formulas will be used in optics. So, arithmetic progression, next is AP. Okay, a sequence with a constant difference between consecutive terms, a plus d, a plus 2d, a plus 3d and etc. So, formulas like an is equals to a plus n minus 1 into d. So, if I want to find n terms, the formula is used. If I want to find sum of n terms, for example, these 3 are there, no? A plus, a plus d, a plus 2d, 3 are there. So, if I substitute, I can substitute the value of n as 3. So, Sn is equals to 3 by 2 into 2a plus 3 minus 1 into d. So, sum of n terms and nth term. Next, geometric progression, GP, AP and GP, 2 are there. A sequence in which each terms is multiplied by a fixed ratio. So, ratios in this case, AR square, AR cube, AR power 4, etc. So, for finding n terms, the formula is an is equals to a into r power n minus 1. Okay. So, Sn is equals to, that is sum of first n terms. Sn is equals to a into r power n minus 1 by r minus 1. This is r power n minus 1 by r minus 1, where r is not equals to 1. Okay. If r is equals to 1 means the denominator will be 0, no? So, r should not be equals to 1. So, for infinite GP, like infinite terms are there, they have not given what is the value of n there. So, infinite GP, S is equals to a by 1 minus r, a by 1 minus r. So, where we are using this AP and GP. So, chapters name like kinematic, rotation motion, projectile motion, oscillation, and then nuclear physics, current, electricity, waves, sounds, AC circuit, damping and thermodynamics. These are the chapters we will use AP and GP. The concept where we are using, especially uniform acceleration, constant angular acceleration. Constant angular acceleration in the sense it will comes under rotational motion. Angular, no, the term angular is there, so it comes under rotational motion. Next, equal interval steps near equilibrium, like in oscillation the pendulum travels, no, how many times. So, equal interval steps near equilibrium. Next, radioactive decay, voltage drop in infinite circuit. Next is intensity decay in medium, amplitude or voltage decay. Okay, these are the topics, core topics which we are going to use this kind of AP, GP and algebraic equations. Okay, let us revise one more time whatever we have seen in the classes. So, first we have seen what is algebra. In that, first one is transposition of terms, second one is combining like terms, third one substitution method, fourth one factorization and expansion, fifth one cross multiplication, solving linear equation and quadratic equation. Especially when we are solving quadratic equation, see whether it is a real or imaginary. Okay. Next one, dimensional consistency via algebra. So, this topic, no, especially there is a separate topic in significant figures are units and dimensions. Okay, in that we will see what is dimensional consistency separately. Okay. Next, some formulas in algebra. Next, where we are using algebra, that is Newton's law, kinematics, energy equations or energy, then motion in a straight line or inclined plane, Ohm's law. Next one, some additional formulas. One is binomial approximation method. The formula is 1 plus x power n, where x is much less than 1. Then I can write the formula as 1 plus nx. Second one is component and dividend rule, where we are using this one is in ratios, equal ratios are there. So a plus b by a minus b is equals to c plus d by c minus d. And then arithmetic progression, geometric progression. So in today's class we have completed algebra. So in tomorrow's class we will see what is logarithm and trigonometry. Up to that, thank you guys.